Dobry wieczór. Nazywam się Jeronimo Martinez i to wszystko, że mogę mówić po polsku. Unfortunately, my Polish is not that great. I can have a fluent conversation with a 3-year-old only. So for the rest of the conversation, of the talk will be in English. I hope that it's not a problem for you. As I said, my name is Jeronimo Martinez. I'm a software engineer at DataArt. Well, right now I'm working as a data engineer more. And today I want to talk about Eta. So my first question will be, who heard about Eta before this talk? Okay, that's good. That means you are going to learn something new. So why Eta? It's a purely functional programming language. It runs in the JVM. And I think it's interesting because it's quite different from any other language, on any other programming language. It has a set of features that other languages don't have all at the same time. It has some background on Haskell, but we'll get to that in a moment. So first, that's the company I work for. Again, it's a really nice company. Now we are celebrating the 20 years anniversary. I have a colleague here that will be glad to talk to you after that if you are interested in knowing more about the positions available in there. There are a lot of interesting projects and really nice and smart people working on there. Okay, so what are the contents of this talk? So I'm not going to show you how to program in Eta because it's very different from other languages, and I have only 45 minutes. So it's impossible that you will learn a new language in 45 minutes. So instead of that, I'm going to tell you what makes Eta special or different from other languages, then what's the current state, and finally, why are you here? Why do you want to listen or even try this language that you haven't heard about? So, and finally, some questions and answers. So this is like a family tree of programming languages. At the top, it's like 1950s. So that's basically the time when the first, yeah, much better? Yeah. Okay, sorry. That's basically the time when when the first programming languages appeared. There were like two branches that were discovered at the same time. One was based on lambda calculus, functional, and the other is based on imperative code. So the functional side was very theoretical. There was a lot of people doing research in programming languages in that side, and not a lot of happening. While in the imperative side, there was a lot of interest from industry. So a lot of companies started using programming languages for their daily business. And you can see there is a lot of things going on in that side. Then around the 70s, there was object-oriented programming, so a lot of C++, Java, it's in that side. And in the last 20 years, they started becoming together. So there was not a lot more happening in the object-oriented side, but a lot of features were interesting in the functional side, and languages started combining them. And that brings us to nowadays I think there is a lot more things going on in the functional side, and probably you have heard lately a lot about that. So it's like a buzzword, and everybody wants to do functional. So I highlighted 4 different languages in there. I think they're relevant for this talk. Java, I assume that you already know Java because it's a Java group. I'm not going to say a lot more about that. The other one is Haskell. So how many of you have heard about Haskell before? Okay, that's not too bad. Yeah. So Haskell, it's as much functional as you can get. So if you have in one extreme, you have imperative, you have C, for example. In the other side, you will have Haskell. It's totally the opposite. And it was a research language, so it didn't get a lot of attention at the time. But later, I think recently it's becoming more popular, and there are already a lot of companies using that in production. So it's a really simple language, although you can build a lot on top of it. So the level of abstraction can get a bit complicated, as much as you need. And some people thought, okay, maybe Haskell is nice. It's a mathematical language. It's functional. Why cannot we use that more in industry? Because everything is dominated by Java and C#. And some people said, okay, let's try to make a language. We're still writing Haskell, but it runs in the JVM. It integrates with all the other enterprise software that exists already there. And there was a first attempt, which is called Fretch. Probably nobody knows about that. So they took the language, Haskell, and make it compile to Java bytecode. But it was a slightly different language, a bit different enough so that you cannot reuse any of the existing code that was there. So it didn't become very popular. Later, there was another group of people who said, okay, let's do this right. They took the Haskell compiler, actually the front end of the Haskell compiler, and they just wrote the backend. So effectively, Eta and Haskell is the same language. The only difference is that Eta runs in the JVM and it has some way to interoperate with Java, with existing libraries. So now these are the 5 properties that makes Eta special. I'm going to cover each one of them separately. So if you take the first 4, that's what Haskell is. And if you add the 5th one, JVM interoperability, that's what Eta adds that no other language has. So let's start with the first one, what it means to be functional. Probably you already know that, but we have to start with explaining what's a function in the mathematical sense. So from primary school, you remember the sets. From X is the input, then you have outputs, and a function is something that maps inputs to outputs. From each one on the inputs, you can only get one on the outputs. Another way of seeing that is like a kind of a pipeline. You have input, function, output, and the output only depends on the input, nothing else. So when you are doing functional programming, you don't have statements. Instead, you only use expressions. Another way of saying it is like programming with only expressions. That's if you're not familiar with it, it could look a bit strange at the beginning. Like, how can you do programming with the for loops, with the assignments? But I will explain that in a few seconds. Also, you have the property that functions can be treated as values. So you can pass it as parameters in your other functions, and you can get functions returning from other functions. And those are called high-order functions. An example of that will be composition. And that's how you would write composition in Java, for example. So Java already has a lot of functional features, especially since Java 8. And you can do a lot of stuff with that. But it doesn't feel natural. It is a lot of boilerplate in there. That would be the equivalent in Eta. Don't worry about code, because I haven't explained how Eta is written. That's not the point of the talk. But I just pointed here to let you see how simple and short you can express ideas in there. So the first line in the Eta side is the type of the function. Dot is the composition. The second line is the implementation. So composition is just you have one function here, another here. Just connect the output to the input of the next. That's basically the idea. And it's one of the most common constructions that you use in functional programming. So the next property is pure. So here you have a pure function. It looks like that, basically. You have input, output, and nothing can affect the output other than the input. In the impure side, you can have a lot of arbitrary effects that can influence the output that doesn't really come from the input. And examples of these kind of arbitrary effects are any kind of I/O, so networking, reading or writing to networks, disk, database, mouse interaction, keyboard, screen, like drawing the screen. All those are side effects. exceptions. If you have an exception inside this body of your function, you don't even have an output. Threads and locks, it can block the execution of your function. It can have a deadlock. It can never return anything. If you introduce randomness, again, you are taking something from the outside of the function, and you cannot predict what the output will be. Having an implicit context, for example, having environment variables or system properties, they are all available like in a global context, and you can use those values anytime you want. So they come from outside of the function as well. That's probably the biggest one, like having shared state. So for example, any object in Java has access to all the internal properties of that class, of that object. So your functions do not depend only on the input as well. And logging. So when you log log a string or a message, it goes actually to the disk. It has an effect outside of the output. So why is purity important? So it doesn't mean that Eta doesn't have side effects. You need to have side effects to have useful programs. I think the difference is that with Eta, you have to make it explicit. And the compiler is going to check that you don't mix impure code with pure code. And it's going to give you an error, compilation error, when you try to do that. In any other language that is not pure, you can put in side effects anywhere you want. So there's no control. It has to be in your head. So also languages shape the way you think. So once you start being aware of where is input and where is pure code and impure code, you start designing your code in a way that tries to keep them apart. So you actually design programs in a different way that you would do normally. So that's what I said. Like this type system is just helping you to know which functions do side effects and which not, and not mixing them. So so I have a little example that will be the input of one of these functions. So it's a text file, contains lines and numbers in those lines. I'm going to present a little program that just goes for every line, finds the minimum and maximum, and subtracts them. So the difference between the max and the min. So that's how it would look in Eta. Again, don't worry, you don't understand this code. The point is, like, the compiler will make sure that you don't mix pure and impure code. The red one is impure. The green one is pure. You don't see the types here, but internally, every single expression contains types. So in this case, read file is just reading the file. Print is the part that prints a list into the console. And calc range is the function that does all the work here, which is what you would expect this function would do. Split into lines, then for each line, split into words, parsing the numbers into ints, calculating maximum and minimum, and subtracting them. So the next one is immutability. So well, that was not one of the initial properties, but it's a consequence of trying to use purity. So when you have a language that is immutable by default, you don't have assignments. That doesn't exist. The only thing you do is giving names to values. And you can only give a value, bind a value with a name once. Once, let's say you say A equals 5, A is 5 forever. You cannot change that. So in that sense, there are no variables because they don't change. So why is this nice? Because you can build immutable data structures. For example, this is a list. It's immutable. You want to add a new element. So you don't change the existing one. You actually append one, but you keep the old one. So the old one is still there. You have a new one, and they actually share some of the elements inside. So when you're writing Java code, for example, when you pass a big object or the big data structure into a parameter, you always have to think, oh, what is this function I'm passing the object going to do with it? Do I have to make a copy of it first, just in case it changes? Or is it a shallow copy? Is a reference? Is a clone copy, like a deep clone? It's all the clone methods implemented in those classes. Well, with immutable data structure, you don't care about any of that, because you know it's not possible to change it. So it makes code a bit simpler. And the point here is, like, sometimes you need mutable states. And Eta is not going to stop you from doing that if you need, but it tries to discourage you from using it, or at least to put it really, really in a single place. So you don't do a lot with that. And that makes it easier as well to write code that is concurrent and don't have deadlocks, and it's easier to parallelize. So that's what I meant by the language changes the way you think. So I think it encourages you to write code that doesn't use mutable state. But you can do it if you really need. So as an optimization, some algorithms, the best or the most efficient implementation is mutable. So in that case, you can use it if you want. But it would be implicit in the type of the function if it uses mutable, uses some mutability in it. So the compiler will know the parts that you are using mutability. Yeah, that's tracked by type system. OK, so the next property is statically typed. That's probably you know already. Java is a statically typed language. So it's guaranteeing that you don't try to use the types in the way they are not supposed to. And it does that at compile time. The difference with Eta is that it has a very sophisticated type system. So you can get types as much complicated as you want. Well, complicated maybe it's not the best word. It's sophisticated or advanced. And those are applying constraints to your types. So it can do less things or fewer things that a function with a simple type. So you don't have to specify all those types because the compiler is smart enough to do inference. You can specify the types explicitly if you want to check that you are doing the same thing as the compiler thinks. So you are on the same page. And then it makes a lot of use of generics because when you have a generic function, it actually restricts a lot the type of implementation you can do because you don't know anything inside these generic parameters. So an example would be that. That's a type definition. F is a function. It's a function whose input is a generic parameter, and output is the same type of parameter. So in Eta, there's only one way of implementing this function because you don't know anything about the input A. So the only possible thing that you can do is pass it through to the output. So this is only a single implementation. In Java, this is kind of equivalent to that, but the compiler is not guaranteeing. It's not guaranteeing that you are not doing any side effects inside the implementation. So they're not really equivalent. Something equivalent in Eta would be something like that. So in that case, you say, OK, you have a generic parameter A, but the output can do some side effect. That's I/O. So imagine that you are just logging A into the console. So if you want to do that, you have to specify that in the type of the function. You have to say the output is A, but it's also doing some side effect. And not only that, A cannot be anything. It needs to be something that you know how to transform into a string. So that's what the show A means there. And if you want to be more explicit even, so I/O is side effect, any side effect, you want to say, oh, it only logs. So you can create a more sophisticated type. So this is is outputting A, but it's also writing a string into some other list that's kept in the context. So this is only logging. So you can get as much specific as you want. OK, so Thanks to that, you increase the safety, so you don't have to write so many tests when you are testing your code, because the compiler is already catching a lot of this type of mismatches between types. And compared to dynamic languages, if you have programming in Python, JavaScript, you know you have to write a lot of tests if you want to be sure that the code is doing what it needs. Sometimes you write more tests than the code you are testing. And because the powerful type system, I think it's very easy to refactor code. Anytime you change something that should not match, it will be flagged. And because it's so restricted what you can do, if you do make a little mistake, probably it will pop up as a compiler error. So this is a small joke, but it's not so much a joke. It's actually, I feel it's true when I have done this. In the dynamic typing, yeah, everything, you go really fast at the beginning, everything, you put all the pieces together, and you think it works, but then you spend a lot of hours debugging until it works. Well, you have really, really strong static typing, then fitting the pieces is not so easy. You have to really think beforehand, you have to put them together, and you have a lot more chances to get the right picture at the end. So the next one is laziness. And again, there are not so many languages that are lazy. Very little. Most of the languages are strict, which is the opposite. So, but they allow you to have laziness in some specific parts. So I think Java has a lazy construct. It means you have here an expression, don't evaluate it until I really need the value. Until that, just wait. In Eta, that's the default. Every single thing is lazy. It is lazy by default. And it lets you do things that you cannot do in other languages, like, for example, infinite data structures. So why are they useful? Here is an example of how you define one. So this is a list. Once is a function, and it produces a list of ones. So that's how you define it. It's recursive, and it never ends. So that's not a problem as long as you don't request all the items in the list. But you can. It's similar to a generator. So that's another lazy recursive function, Fibonacci numbers, and you can define it based on itself. And it only generates things, elements, as you request them. So it's easier to write modular software. You don't have to worry when things are evaluated. Another example is finding the nth element of a list based on some order. So in this case, what this is doing is sorting it first, and then indexing the nth element. And that's the most immediate answer when you want to solve this problem. I sort it first, and then I find the nth element. But it's not the most efficient. In a strict language, you would use another different algorithm, like quick select. But in Eta, you can just use the simple solution. And when you query the nth element, it's only going to sort enough elements to know the element that you are requesting. It's not going to do any more work than that. The downside of laziness is that it's very difficult to predict when things are going to be evaluated. So if you are mixing laziness with side effects, it can get a bit tricky. But again, the compiler is going to help you in this way. And then a bit mentioning about abstractions in object-oriented languages. I'm sure you know all these object-oriented design patterns. There's like a book with 23 of them, and they asked about them in every job interview. So why do you need to remember all those? Why do you, or even worse, why do you have to implement them again every time you need to use them? I think it's because the language is not expressive enough to turn them into a library. So you can say import visitor, import strategy. You cannot do that. You have to implement every single time what they do. In functional programming, there are also patterns, but usually you can turn it into libraries that you can import. they usually become something called types classes, with something similar to interfaces. So these are names of some of the functional design patterns. I don't know if you are familiar with them or you have heard, probably because they are started to leak in other mainstream languages. I think soon they will be quite popular. And then the point of this is like when I only knew about object-oriented programming, I thought that, okay, that's the most advanced things you can do. But that was quite a long time ago. It was like 15 years ago when I think there's not a lot more happening in object-oriented, not new discoveries. I think it has moved to other areas after research and new new programming language features. So I think when you are stuck in some paradigm, sometimes you have to go a bit down and then reach another one that lets you abstract and reuse software in a different way that lets you do more complex and useful abstractions. I'm not saying that functional is going to be the best. Maybe, I don't know, in 10 years there will be another mountain of something else that we don't know. But I'm more comfortable knowing that it's available for me to choose if I need to. And then the last one of the properties is Java interoperation. I'm going to go a bit fast here. So it's there's a fundamental difference between object-oriented and functional. So object-oriented encourages you to have to use messaging between objects and encapsulate internal state, and functional discourages state at all. So how you can match them? Some languages like Scala try to do both things at the same time. So when you are doing Java interoperation in Haskell or Eta and Java, it's like you cannot really write Java code in Haskell. You can, but it feels unnatural. So one of the best things that you can do if you want to interoperate is use static pure functions. But if you really need to use Java code, so that is ways to do that. So it's called a Java wrapper type, and you can get objects, you can call methods. It's everything you can, but it defeats a bit the purpose of using a functional language if you have to use object-oriented underneath. So in this Java interoperation, you can import code from Java. You can export Eta into Java as well. You can Marshall convert primitive types and arrays between the two arrays automatically, and you can even simulate inheritance by a feature called type families. So Eta doesn't have inheritance. It doesn't really make sense in the functional world. So here I have a really quick example of a little program. So I went. So the program is wildcard pattern matching. So the same thing that you will find in the command line when you want to find files in there. You have a pattern using star and question mark, and it will try to find if the name of a file matches that pattern or not. So the standard implementation of this is using a regular expression, and that's really fast. But for the benefit of the talk, I went and tried to find some Java code that does that already in some library, and I found one implementation of this in Apache Commons IO. So again, don't look at the code. This is just to give you an impression of how complex this thing can be when implemented using an imperative way. So I'm sure that whoever wrote that didn't get it right the first time. There was a lot of testing and debugging because there's a lot of nested ifs, for loops, indexes. Probably took a few hours to get to something working. So I will show you an example of how you write that code in Eta using some of the nice features like pattern matching itself. So that's the same function. It does exactly the same as the previous function. So it's a recursive function. The first line is the type of the function. You give a pattern, a string, and it tells you if it's true or false that matches it. The next 3 lines is the base case. The other 3 is the recursive one. So this is a lot more. First, it's shorter, and shorter is always better, almost always. It's simpler, and at this point you would say, oh, you went and try to find the worst code possible for Java in internet, and that's a bit true. I happened to find that, but the point is, you can write this code in Java as well. That's the same implementation in Java. So it's a lot shorter. It really looks like that. But maybe you don't think about this the first time. You try to implement it imperatively. This is not super efficient because it's trying to use some kind of, it's using the string and a lot of substrings there, which is not great. But you can find some Java libraries that have the same type of list that Eta has. And then now it's as efficient as Eta. So the point of this is sometimes functional style is better. It's more natural to get to a solution than imperative. And it's great if you have the choice of or the knowledge of, there's 2 options. I can choose the best one that fits the problem. So how is Eta at the moment? Oh, at the moment, I'm repeating this talk. I gave it last winter, so it may have changed a little bit. So let's start with dialect. It's the company that's behind Eta. It was initially founded by 2 people here. They mostly did all the work, and it's quite amazing the amount of work that only 2 people can do in such short amount of time. The main focus of what they are trying to do is provide commercial support. Actually, someone that you can call when you have problems, make something that is fit for enterprise and that can integrate with all your Java existing code. It's still at a very early stage, so I'm sure that you haven't heard about it because it's not very popular at the moment. They say it's close to production already, but until they get to version 1, I would just be careful. And one of the nice benefits is you have all the libraries that are available for Java and all the libraries that are available for Haskell. You can combine them and use them. They are already ready for that. And there's a huge ecosystem already in Haskell as well. So there are libraries in there that you don't find in other languages, like especially when it comes to parsing. And it's a huge benefit that you can interact with both languages at the same time. So they have already package manager, built-in tools, many installation methods. That's the main web page that you can go to get more information about it. The GitHub, and then that's an interactive tool on the web that you can do just to learn the basics of the language if you're interested. And then a community. That's the link for you want to know who else is doing, or at least interested in Eta. And what's going to happen in the future? They are working in IntelliJ plugin. So because enterprise companies and developers, they really like to have integrated support. I mean, one of the nicest things that Java has is that IntelliJ and auto-completion, and that's really enhancing your experience while writing the code, and they identify this as a key point, so to involve more people. Bindings for very popular projects like Apache Spark. So right now you can write Apache Spark in Python, Java, and Scala, I think, and so you have another option is to write your Spark in Eta. Simpler interoperation between the 2 languages, so you don't have to define imports explicitly, so that it will be a bit more automated. Some tool that converts Java code into Eta. I don't know how useful is that. I think the whole point of using Eta is not to write Java-like code, but it's going to be there. Maybe it's interesting. Improving documentation and tutorials, and providing a different backend. Not only JVM, but also Android and compiled to native as well. So they are quite aware that a big factor in the success of Scala and Clojure is because it was compatible with JVM. So they are going to try to play the same game, giving you the ability to not convert your whole project to Eta in one go, but small parts, maybe this test, maybe this library, and you can do it gradually. I think it's less risk, especially when it comes from enterprise software. And final question, why would you use it? That's really a good question. So first, I'm going to talk about why it's useful to learn it, even if you don't use it. I think it's a change in the way you program. At least for me, when I started learning Haskell first, and then I became interested in Eta, it's just you have basically to forget everything you have learned about programming, and you have to start solving problems in a completely different way. It's some say that it's more mathematical, but it's still programming. It's just different mindset and a different tool for solving problems. So instead of writing statements and giving instructions to your computer, you start like designing programs that started with small, and then you compose it into bigger ones. And I know that sounds a bit simple, but once you start seeing how that thing works, it's really enlightening. You become more aware of side effects. Before, you put side effects everywhere where you need them. Now you start thinking about them. Maybe if you are not using Eta, the compiler will not warn you when you are doing that, but at least you learned how to isolate them, or you are aware when you are using side effects, say, okay, maybe I should not do that here, because later it will be much more difficult to maintain this code. Let's try to isolate it and contain it in a single place. You start reducing mutable state as well. Again, you only use it if you need, because programming with immutable state is so much easier. Mutable state, I think most of the time it's an optimization, and it's fine, but if you can avoid it, it will make your code a lot easier. And Eta and Haskell, they have something really nice that it's called software transactional memory. It's some pattern or library that lets you compose functions and almost guarantee that you are never going to have deadlocks in it. And you can, like when you use Java code or any other language, so you have a function, you know that there's no deadlock. You have another one, it starts calling each other, and suddenly you have a deadlock. And it's sometimes difficult to know what each function is calling downstream. So the compiler can help you with that. It will guarantee that you don't have deadlocks. Again, you get state-of-the-art programming language features. So you remember the diagram with the family tree of languages. Haskell was there since the 1985, much earlier than Java. And most of these features were already there. And it's only now that all those features are leaking into other languages, becoming popular. But they were already there. So when you have new features coming, usually you look at Haskell, oh, they were already there. And the next version of Java comes like 12 or 13 or 20. It will come with a lot of features. Most of them will be related to functional. That's my guess. And instead of trying to figure out what this new feature is, I think your reaction will be, oh, it was about time that you get this in Java. Now I can write code a lot easier. So if you look at this Eta and Haskell, you'll get a lot of new, like, state-of-the-art programming features. And I think you can transfer that knowledge easily. So right now, a lot of functional concepts are reaching any other language. And finally, so why would you actually use it? So these are the benefits that you get, like really strong, that no other languages guarantees. Strong focus on correctness. So that's probably the biggest thing. So sometimes you write programs that you don't need this correctness. It's like really, really strict. Sometimes you need. And in those cases, Eta would be a really good option for that, because the compiler is really getting your back. It's really helping you to write correct code. You catch a lot more errors at compile time instead of runtime. Also, functional programs tend to be shorter, and you have to write fewer tests because the compiler will check out more things for you. Code bases are usually easier to maintain when they become big, because then you get help from the compiler. It's not just trying to understand every single piece of code. You get guarantees of what a function can do just by looking at the type. Sometimes you don't even have to look at implementation. And if you make changes, again, it breaks a lot of things, and the compiler will let you know about that. I mentioned that before. Mutable data flows are a lot simpler, and concurrency is easier. And Eta and Haskell, it's a very simple language itself. It has a core language that doesn't change very much. It doesn't have a lot of surprises like JavaScript, or that sometimes you get in Stack Overflow. What is something equals something else, and it gives you a crazy answer. So that doesn't really happen in Eta, and you can get very powerful abstractions building on top of that. And I like this sentence. It has no tolerance for imprecision of thought, which means you really need to have a clear idea in your head of what you are going to build. You really have to think about every corner case just to make it compile. If you want to write code in a quick and dirty way, doing prototypes that produce the right value half of the time, this is not the language for you, because it will not let you even run it. But if you want to make sure that you think everything through before, I think this is going to help you a lot. And again, when you are trying to write code, most of the languages depend on being a really good developer, keeping a lot of things into your head, following best practices, having ninja skills. Sometimes you don't have to depend on all that, just have it all in your head. Sometimes the language can help you with that. So you don't have to be a super programmer, just let the compiler help you. So I hope I gave you a broad overview, really overview of the language, that at least I have sparked your interest, and you will check how it works. And that's all. Let's go to some questions and answers if you have. Yeah. Some microphone somewhere.
What is the real use case for Eta? Because everything what you show was just Haskell, almost Haskell. And I think Haskell is awesome language. It also changed my life a lot. I have started thinking about development completely different way.
Mm-hmm.
So question, why you should prefer to use learn Eta instead of Haskell?
I think there's a lot of personal interest in saying this language is actually clean and beautiful. I really like it. It's really maintainable. I think Haskell already has proved that big projects are maintainable. I think there are a few examples already in the industry doing that. But adoption is not great. I think one of the reasons for that is that everything has a dependency on existing software. With a lot of it runs in Java. So this is like trying to bridge the gap between those two. I agree that currently probably you want to find a job in Eta, the chances are 0. But I know in Haskell there is, and everybody who learns the language, it really becomes really happy about it and wants to use that in their daily job. So if we can bridge that gap, I think that only that is going to be a big plus. But again, another question I get a lot is, do you use it yourself in production? And the answer is, there are a few reasons why I'm not doing that at the moment. For now, it's just a hobby. I learned Haskell, and then because my team was working in Java, I became interested in like, maybe I can start doing that. But your team really needs to agree on the technology. You cannot just be the only one writing it. You need to have an expert in the team just in case you get to a blockage and you know how to proceed. And because of that, I'm trying to do some evangelization about that. So this is part of that, actually. I run these presentations with my team. I try to convince them that this is how it looks. Once we agree that they like that and they can write software in a better maintainable way in there, it will be the time, but not before. I think at the end, to answer your question, it's a question of personal preference. I think this writing code in Eta gets the best of me. And if I can make that useful for my clients, that will be the next step.
Okay, my second question is about side effects, because Haskell doesn't have side effects. There is option just to add side effects, and mark is okay, there are side effects. And after that, how your code look like? There is like side effects infect your whole application or not?
Yeah, you can call it like infect or make it dirty, but it's not that Haskell doesn't have side effects. It has side effects, but they're explicit. I think that's the little difference.
IO operation, yes?
Yeah, IO operation, it's mostly IO operation, okay? And so the way you structure programs like that, usually you have some core functionality that is pure, and then you build your impure code around that, like a shell that uses the internal functions. So you try to push all the impure code to the top. How to say that? So I didn't want to get into talking about monads, but there's a pattern in Haskell that's based on monads and monad transformers that try to make that thing easier. And probably in Scala, if you are familiar with that, they have something similar, but Scala allows. Yeah, like Scala started using or taking a lot of ideas from Haskell, and there are a few functional libraries. Actually, later we can talk about that because I would be interested to know your opinion on their side. But you can write completely normal programs in Haskell and Eta. There's nothing stopping you from using side effects. It's just you need to be explicit and you have to think about them beforehand, how you want to structure your code. But it's not that it's not possible.
Okay, so side effects means just monad IO, nothing more. It's not like piece of code doing something in background, but just monad IO, exactly.
I mean, everything that is a side effect ultimately runs in the IO monad. Yeah.
Thank you.
Let's suppose that I would like to start coding in Eta, and so far I know that there is no IntelliJ plugin to help me, but my question is there a existing toolchain that would help me in implement my part of my project in Eta and then provide, for example, a jar file to the rest of my project to use it?
Yeah, the toolchain exists. The IDE plugin doesn't exist yet. I don't know if there will be something in Emacs. At least you'll get the minimum. You'll get syntax highlighters because they are basically the same as Java. I know that for some IDEs that you have the highlighters, but not the type of help that you get with a plugin, IntelliJ plugin. Okay, but that was in the pipeline in last winter. I have to check how it is now. I don't know. Maybe there's some more progress in the plugin. So
for the time being, I'm able to
so
generate a jar file with for example, and then use the jar.
Yeah, you have command line tools, compiler and package manager, builder, and they will generate a jar, a .jar file. And you have also Gradle to.
Okay, and when I'm using the Java interoperability features, am I provide with some interface to the function, or how does it look from the Java program when I'm incorporating a jar file written in the Eta?
I think the best way to do that is to provide an API that looks functional. So most of it will be static functions. I think that's the natural way. I think you cannot build classes and objects in Eta and then it's not possible to do that and then expose them as Java. I think it's mostly pure static methods.